Good morning. Today we will see about this Quine-McCluskey or tabulation method of minimization. Previously we have seen that K-map minimization method. And what is the limitation of that K-map is if the variable exceeds 5-bit or 6-bit, it is very difficult to solve by using that K-map method. That's why we are going for this Quine-McCluskey method or tabulation method of minimization. Now let us solve this problem. By solving this we can easily understand. Simplify the Boolean function by using Quine-McCluskey method, that is f of abcd is equal to summation m. So by seeing this summation m, we can say that this is minterm or sum of product. So f of abcd is equal to summation m 0, 2, 3, 6, 7, 8, 10, 12, 13 and so on. We can write up to 15, 20, 25, 30, 35, 40 and so on. So we can solve for any n numbers. So that is the advantage of this Quine-McCluskey method. Now what is a step 1? So we'll solve step by step. This is our step 1. So in the step 1 we have to represent this minterm by using binary representation. So first let us represent. Form a table, write minterm and here binary representation. And what are the variables they have used in the question? That is A, B, C, D. And now what are the minterms that is given in the question? That is M0, M2, M3, M6, M7, M8, M10, M12, M13. And we know how to write this in the binary by using 8421 code. So 0, 2, 3, 6, 7, 8, 10, 12, 13. So first step is to represent in the binary. Then the second step is, now we have to group this by using number of ones. So we must check number of ones. If we have only one, then we have to take that as the first group. If we have 2 ones, then we have to take that as the second group. Then 3 ones as the third group. Let us move on to the next step. So this is our step 2. Let us move on to the step 2. Now check this. Here we have number of ones. So we have to represent by using number of ones. Then write minterm. Then write binary representation. And we know that we have to represent by using A, B, C, D. Now check this minterm. Here we have only zeros. We don't have 1. For M0 we don't have 1. So number of ones is 0. We don't have any ones here. That is M0. So minterm is M0, 0, 0, 0, 0. That is our first group. Then come to the second group. Number of ones. Let us take number of ones. 1. Here we have only 1, 1. Then check here. Here we have only 1, 1. So we have only 2 minterm. That is M2 and M8. So write M2, M8. Represent this in the binary representation. This is 2 and then this is 8. Then check for 2 ones. So here we have only 2 ones. That is M3. And check here we have only 2 ones. M6. Then check here we have only 2 ones. M10. And this is M12. We have only 2 ones. Now write this in the number of ones 2 group. That is M3, M6 and M10, M12. M3, M6, M10, M12. Now represent this by using binary. That is 0, 0, 3, 6, 10, then 12. Then move on to the number of ones, 3 ones. So that is 3 ones, M7. And here we have M13. So 3 ones, M7, M13. 0, 1, 1, 1. Then 13 is 8, 9, 10, 11, 12, 13. So this is our step 2. Then the next one is step 3. So in the step 3, what we have to do is, now we have to compare this binary, that is 0 group with 1 group, 2 group, 1 group with 2 group, 2 group with 3 group. We have to compare and we have to check for only 1 bit changes, where we are getting only 1 bit changes. Again we have min term and binary representation. Again write here A, B, C, D. Write A, B, C, D. Now compare this M0 and M2. Where we are getting changes, we have only 1 bit change in the place of C, isn't it? Now compare this, write this binary representation, that is compare the 0 and 2. If you compare 0 and 2, we will get 0, 0 common, 0, 0, but here 0 is changed to 1. So there we have to represent dash, and here we have 0. Then compare the 0 with 8. If you compare the 0 with 8, here we have 0 is changed to 1. So compare 0 with 8. The 0 is changed to 1. So here you can represent dash. Then the remaining will be 0, 0, 0. Then now compare this 1 group with 2 group. Compare this M2 and M3. 0, 0, 1, dash. Now compare 2, 3. 0, 0, 1, but here the 0 is changed to 1. So we have to represent this as dash. Then compare this 2 with 6. We cannot compare this 2. We cannot write here. No, we can write this. Now 2, 6. Compare this 2, 6, 0. Then here 0 is changed to 1, dash. This 2 bits are 1, then 0. Now compare this 2 with 10. 0, here we have 0, but here we have 1. 2 with 10. Here we have 0 and here we have 1. So represent this as 0, 1. So represent this as dash. Then the remaining will be same, 0, 1, 0, 0, 1, 0. Again compare this 2 with 12. Now compare this 2 with 12. Here we have 0, 1. Again this bit has changed, 0 as 1. Since we have 2 bit changes, so we should not write this here. Now go to the next one. 8. Compare this 8. We have completed this 2. Now compare this 8 with 3, 6, 10, 12. Now compare this 8 with 3. Here we have 1, 0. Here already we have 1 bit change. And here we have another bit change. Here we have another bit change. So it is not possible to group this. Now compare this two. 1 is changed to 0. 0 changed to 1. 0 changed to 1. 0 changed to 0. So it is not possible. Now compare this 8 and 10. 1, 1, 0, 0. So we can write 8, 10. So here we have 1, 1, 1, 0, 0. Now here 0 is changed to 1. So dash. Then 0. Now compare this 8 with 12. It is possible. So 8, 12. Compare this 1, 1. Then 0 is changed to 1. So represent dash. Then the both bits are same, 0, 0. Next, move on to the next one. Now compare this 3 with 7. Now compare this 3 with 7. 3, 7. Now compare this to 0. 0 is changed to 1, dash, 1, 1. Now compare this 6 with 7. 6, 7. 0, 1, 1, dash. Now compare this 10 with 7. 1 is changed to 0. And here we have lot of changes. So it is not possible. Now compare this 12 with 7. So 12, 7. Here we have dash. Not possible because see here 1 is changed to 0. 1 is 1. But here we have changes. So 12, 7 is not possible. Now compare this 3 with 13. 0 changed to 1. 0 changed to 1. So not possible. Now compare the 6 with 13. 0 changed to 1. Again here 1 changed to 0. Not possible. Now compare this 10 with 13. 1. And here 0 changed to 1. 1 changed to 0. Not possible. Now compare this 12 with 13. So 12, 13 is possible. So 1, 1, 0 dash. Now let us move on to the next step. So after this we have completed step 3 and the next one is step 4. Now what we have to do in step 4, now repeat the step 3. We have to repeat the step 3, compare this group with this with next higher group. Next compare this second group with the next higher group. Now compare this 0 to, again write this minterm and binary representation, that is A, B, C, D. Now compare this 0 to 2, 3. Again here we must have only one bit change. Now compare the 0 to 2, 3. Here we have 0, 0 and here we have dash. So not possible. Check for dash first. Where we are getting dash. Okay. Here we have dash. Now we can compare this first before going to this. Check where we have dash. We have dash in the third bit. So it is not possible. This is not possible. This is not possible. Let us move on to this 8, 10. Now compare the 0, 2 and 8, 10. Here 0 is changed to 1. 0 dash 0. 0 to 8, 10 is possible. Now write 0 to 8, 10. 0 to 8, 10. If you compare this, we will get, listen here, if you compare this 0 to 8, 10, we will get dash, then 0 dash 0, 0 dash 0. So we have compared this, and the here also it is not possible because we have dash in the third bit, so not possible. Now compare the 0, 8. We have dash in the first bit where we are getting dash here. So again 0, 8, 2, 10. So both are same. So no need to write 0 to 8, 10. Again 0 to 18. So both are same. No need to write this. Now let us move on to the next one. That is 2, 3. Compare this with this 3, 7. Where we are getting this dash in the last. Now compare here 2, 3, 6, 7. 0, 2, 3, 6, 7. 2, 3, 6, 7. Now compare this to 2, 3. Compare with 6, 7. 0. 0 is changed to 1. 0 dash. 0 dash. Then here we have 1. Sorry, 1 minute. 2, 3. 2, 3, 6, 7. 0 dash 1 dash. 0 dash 1 dash. 2, 3, 6, 7. 0 dash 1 dash. Next we have dash in the 12, 13 also. Now compare this. It is not possible because here we have 0, 0, 1, 1. So here 2 bits are changed. So it is not possible to write this. Then let us move on to the next 2, 6. Here we have dash 2, 6, 3, 7. So 2, 6, 3, 7. Again we are getting the same number 2, 3, 6, 7. So no need to write. Then we have 2, 10. Not possible. 8, 10. We have dash in the third bit, not possible. 8, 12. We have dash in the here second bit. But we cannot compare this. We have 1 bit change, 2 bit change, 3 bit change. So it is not possible. So finally we are getting this minterm as 0 to 8, 7, 2, 3, 6, 7. Then step 5. Let us move on to the step 5. The step 5, we have to list the prime implicants. We have to list the prime implicants. Before that we should know what is prime implicant. Prime implicant means the remaining terms. So we have to represent these two terms. Along with that we have to represent the remaining terms which is not matched in the previous step. So here this 8, 12 we have not matched anywhere. See 0 to 8, 10. 0 to, now cross check. We can cross check this. 0 to 8, 10. And again 0, 8, 2, 10. Both are same. That's why we have given this tick mark here. 0 to 8, 10 and 2, 10, 8, 10. Then we have 2, 3, 3, 7. 2, 3, 6, 7. 2, 3, then 6, 7. So 2, 6, 3, 7. Both are same. Then what are the remaining missing terms which were not matched in the previous step? That is 8, 12 and 12, 13. So 8, 12 and 12, 13. We have to write everything. So write this as prime implicant. This is our step 5, right? Prime implicant, and we have to represent a binary representation, that is A, B, C, D. Now what are the prime implicants? That is 0, 2, 8, 10, 2, 3, 6, 7, 0, 2, 8, 10, then 2, 3, 6, 7, then the remaining term, that is 8, 12 and 12, 13. 8, 12 and 12, 13. So we have to represent the terms which are missed in the previous step. So while checking this, these two terms are missing, 8, 12 and 12, 13. Now these are the mean terms. Now we have to represent this, that is dash 0 for 0 to 8, 10. For 2, 3, 6, 7, that is 0 dash 1 dash. And what is 8, 12? Now check the previous. What is 8, 12? 8, 12 is 1 dash 0, 0. So that is 1 dash 0, 0. Next, what is 12, 13? 12, 13 is 1, 1, 0 dash. That is 1, 1, 0 dash. So we have completed up to this step 5. And what is the last step? The last step, what we have to do is, now represent this. This is called as prime implicant table. This is prime implicant table. Now what we have to do is write this prime implicant here and write the mean terms which is present in the question. Now what are the numbers present in the question? That is, now refer your question. We have 0, refer this question and write the numbers in the min terms. 0, 2, 3, 6, 7, 8, 10, 12, 13. So this is the number which is present in the question. Now what we have seen in the previous step. What are the prime implicants? 8, 12, 12, 13. So 8, 12, then 12, 13. Then the last what we have seen as prime implicant is, now write the prime implicant from the previous step, that is 0 to 8, 10, 0 to 8, 10, then 2, 3, 6, 7, 2, 3, 6, 7. Now what we have to do is, just this is very simple thing. Now represent this. This is called as prime implicant table. Just nothing. This is very simple. See here. What are the numbers present? Just what are the numbers present? You put cross mark. 8, 12. Then 12, 13. Then 0, 2, 8, 10. Then 2, 3, 6, 7. That's it. This is called as prime implicant table. Now what we have to do is check where we are getting only one X mark. Here we have only one X mark. Here we have only one X marks. And here we have only one X, and here we have only one X. Now write what is the number. Here we have 0, 2, 8, 10. And here we have only one X mark, isn't it? So that is 2, 3, 6, 7. And here also we have only one X mark. This everything represents the same, 2, 3, 6, 7, 2, 3, 6, 7. And here we have X mark that represents 12, 13. 12, 13. Just refer this column and put tick mark where you are getting only X. Only one X. So here we have only one X, and here one X, one X. Refer this columns and put tick mark where we get only one X. Now write the min term for this from the previous. What is 0 to 8, 10? What is the min term for the 0 to 8, 10 is dash 0 dash 0. For 0 to 8, 10 dash 0 dash 0. So dash 0 dash 0. Now what is the min term for 2, 3, 6, 7? Now refer for 2, 3, 6, 7, 0 dash 1 dash 0 dash 1 dash. For 12 and 13, for 12, 13, 1, 1, 0 dash. That is 1, 1, 0 dash. Now we are in the last step. Now see here, this is A, B, C, D, isn't it? Wherever we have dash, we should not consider that. And here we have B and D alone. and actually 0 represents B bar, and here 0 represents D bar. That's it. And here just omit this dash. Here we have A and here we have C, but actually A is bar because 0 represents A bar in min term. Already we know about this. Here we have A, B, C, but C represents 0, that is bar. Therefore, the final expression by f of A, B, C, D, which is equal to B bar, D bar plus A bar, C plus A, B, C bar. This is a minimized expression for this sum. Now, just let us see one glance how we have to do. This is question Quine-McCluskey method. What we have to do is simplify. We have to simplify this numbers. First step is write this by using binary representation. This is your first step. And your second step is write number of ones. According to number of ones, we have to separate this. So 0, we don't have any 1 here. So this is 0. Here we have only 1 1. Here we have 2 ones, and here we have 3 ones. Then the third step is now compare this lower with the higher. This one group with the 2 1 groups. Then 2 1 groups with the 3 1 groups. We must get only 1 bit change. Now let us take for example, if 0 is compared with 2, 0 remains same, 0 remains same. Here we have changes. 0 is changed to 1. So we have to substitute dash here. We have to put dash here, then write 0. So like this we have to compare every groups and we have to write according to that. And also we can write step 4 by comparing same thing. Just same, repeat the same and write the next step, step 4. This is our step 4. So there we will get only 1 bit change from 0 to 18 to 367. Now compare this and check which term is not matched in the previous step. Then we have to write that in the prime implicant. This is called as prime implicant. Then the last step is the prime implicant table. So put a table, write the numbers which is present in the question, and the last step which we got as prime implicants, write the numbers, and if that number is present, put cross mark, and finally check for only one cross mark and write that min terms, and finally we'll get the expression. This is how we have to solve by using tabulation method. Hope you'll understand. If you have any doubt, you can ask me in comment section. If you like this, share and support. Thanks for watching. We'll meet soon in the next video. Thank you.